We have been using the main function, the size of function, or the square root function from the included libraries. But how can we create our own function? This video is exactly about that. Functions are in every C++ program. Large applications have hundreds of functions that call each other to create a full functional C++ program. Functions create subroutines and additional logic for a program's code execution. You are required to add the prototyping statement at the beginning of your C++ programming files. The prototype is just a copy of the function definition without the actual execution statements. It seems useless, but without the prototype, the compiler gives you an error. You can have any number of parameters in your function, but they must be used by the calling function. If you have too many parameters, it's best to break down your function into several functions or consider redesigning your code for efficiency. The variables x, y, and z are local variables because they are only available in our function, not everywhere in the program. Those local variables are automatically destroyed in memory after using the function. On the contrary, the variables a, b, and c are global and are available anywhere in the program, and they are not destroyed until the whole program closes. Because global variables are always available, they take up more memory than local variables, which is one reason they are not preferred when they are not needed. And this is the definition of our function. What does this function do? It is pretty straightforward, isn't it? All statements within the brackets are the function's execution code. The function won't execute unless you call it somewhere in your code. Inside the main function, we first call our function d with specific values. A equals 10, b equals 4, and c equals 2. The program prints the discriminant calculated with those numbers. Then, the program asks the user to input their own values for a, b, and c. After the input, the function d is called again, and the discriminant for the user's coefficients is displayed. Notice that once a function is defined and prototyped, you can call it as many times as you want. In fact, you can even save the function in a separate file and include it in another program. Now we move to another important concept in C++, structures. A structure is a way to group multiple variables into one logical unit. Here we define a structure called planet, which contains three variables: its mass in kilograms, its average diameter in kilometers, and its orbital period in days. In the main function, we create two variables of type planet called Earth and Mars. For Earth, we assign a mass of about 5.972 times 10 to the power of 24 kilograms, a diameter of 12,742 kilometers, and an orbital period of 365.25 days. For Mars, we set a mass of about 6.417 times 10 to the power of 23 kilograms, a diameter of 6,779 kilometers, and an orbital period of 687 days. The program then prints all of these values to the terminal, nicely formatted for both Earth and Mars. The advantage of using structures is that all 6 values are now contained in only 2 variables, Earth and Mars, rather than 6 separate variables. This means that if you ever need to transfer or delete all values, you don't have to do it 6 times. You only work with the 2 structure variables instead. For more function usage examples and other types of functions, subscribe.